Welcome to Chapter 5. We are going to be exploring the logarithmic functions and exponential functions and be able to find the derivative of them. Today we're going to start out nice and kind of easy and smooth. Hopefully it's not too miserable for you. We're going to solve an exponential equation where we have fairly easy common bases to work with. So today should be a nice light day. If not, let me know and we will go through some examples together. So if I have 5 to the 3x equals 5 to the x, this is my first exponential equation. Notice we call it an exponential equation, one, because we have the variable in the exponents. So a little background, I guess, what we should talk about first. We have 5 is the base, and the 3x and the 6 here are the exponents, or the powers if you wish. And we see that that variable is in the exponent. Well, if I have an equation, an exponential equation, and my bases are the same, then I know my exponents have to be the same as well. So 3x would have to equal 6. And I can go ahead and solve for x. So in this case, x equals 2. And we can go back and we can put this in if you want. So we have 5 to the 3 times 2 is going to equal 5 to the 6. 3 times 2, of course, is 6. So we have 5 to the 6th equals 5 to the 6th. Kind of makes sense, hopefully. Well, what happens if we don't have a common base? 16 and 8. Well, 16 and 8, definitely not common, not the same. But can we make them into a common base? So what do we know about 16 and 8 and their bases? So we can change 16. So we know 16 is 2 to the 4th. So 2 to the 4th to the x plus 1. We also know that 8 has a base of 2. 2 to the 3rd is 8, isn't it? So now I have an equation where my bases are the same. It may take you a little bit of time to play around with what those bases are. If you took your Algebra 2 seriously, then you should have been quizzed and tested and all that kind of stuff over your perfect cubes and fourths and fifths. If not, you might want to list those out. We do use our thirds, fourths, and fifths quite often at this point in time. So exponent rules, we have an exponent to an exponent. So we know we're going to multiply those together. And here we have an exponent to an exponent as well. We're going to multiply those together. Again, my bases were the same. If my bases are the same, my exponents have to be the same. I can go ahead and solve for x. So we get 4x plus 4 is going to equal 6x plus 3. Solving for x, I can subtract my 4x, subtract my 3, so I get 1 equals 2x. Divide by 2, and I get 1/2 equal to x. And that gives us our answer. I have one last example, a little more complex, but I think it's doable. Here we have 5 to an exponent equals 1/5. So to start, we've got to think about what our base is going to be to be the same. If I think about 1/5, 1/5 is equal to 5 to the negative first power. We can bring that denominator to the numerator by changing the exponent sign. So now I have the bases are the same of 5, so my exponents would have to be the same as well. So I have x squared plus 2x would have to equal -1. I have a quadratic equation. In order to solve a quadratic equation, we set it equal to 0. I can go ahead and factor this equation. So I get x plus 1 times x plus 1 equal to 0. So I know that x has to equal -1. And that's going to give us our solution. So things to remember today in a nice short video that we've got is if you're solving an exponential equation, if the bases are the same, then the exponents have to be the same as well. First thing you want to do, get the bases the same, and that'll allow us to get the exponents equation. Good luck, enjoy. If you have questions, let me know.